Welcome back to our channel. Today we are talking about skip lists, an important data structure that combines simplicity with performance. If you have ever wondered how some systems achieve the efficiency of balanced trees without the complexity, stick around because skip lists might just blow your mind. And it's a pretty important concept when it comes to the pieces. So let's let's try to discover it. So first, what is a skip list? A skip list is imagine a regular linked list now added multiple layers of shortcuts to help you jump over large sections of data. That's the essence of skip list. Okay, let's just take a real example. So let's assume that we have a skip list here. If you want to add a new like item, it's a pretty easy to add because you will add like let's say 7, and you only have to point the head and change the head. So you have the time complexity for update of 1 because it's always the same. However, when you try to make a search for a specific item, let's say that we are trying to search for item number 5. So you have to go from 1, 2, 3, 4, 5. When you hit 5, you return it. So we have in the search time we have O of n. We want to improve that. We want to improve that. How we could improve that? Remember the array that we're using binary search, but binary search are great when we have like binary search are great when we have a sorted array. We can search for elements by splitting everything into twos and in two sections and try to find our solution. But it's not that good when you try to update because updating is really complex. However, let's try to understand how the how basically the skip list works. We said we add shortcuts, but what that means. So, for example, one adds to its points to two. Also, let's make one quite big, and yeah, make it like that, and let's make the pointer down, and make 3 big as well. No, make it as little as. Sorry guys, I'm just trying to make it look good. Mm, okay. And I could make also 5 big. Let's just make 5 quite tall. And oops. Okay, so basically we create shortcuts. So 1 point to 2 also it points to 3, and 3 could point to 5 as well. So if we're trying to search for number 5 here, we don't have to go through each element. We can first go through number 1 to 3 directly, starting from the high level. And when we hit 3, we see, okay, if 3 less than 5, if it's still less than 5, okay, so we go high again. If 5 is less than 5 or equal, we continue. So because we find it directly in 2 steps instead of 1, 2, 3, 4, 5 steps. So this is how fast it will be, and this is what is a linked list. Okay, so let's try to understand again. It's a probabilistic data structure that enhances the functionality of linked list by enabling fast search, insertion, and deletion. With these shortcuts, skip lists deliver performance compatible to balanced trees like B trees, but with much simpler implementation. Okay, so we said that we have a bottom layer. The bottom layer contains all elements in the sorted array. We have a higher layer. The higher layers spares subset of the lower layers, providing shortcuts to quickly navigate the list. We have nodes. Nodes are promoted to higher levels, probabilistically ensuring even distribution without the need for rebalancing. So let's try to break down the mechanism of skip list. First, in terms of the search, we did just the search here, as you can see. And the insertion, we can add new elements to the bottom most layer in the sorted array. So we can add here a new element like 7 or something, and it's easy to add element. Then the probabilistically promote the node to higher layers. This randomness ensures that the structure remains balanced. In terms of the deletion, we locate the node is in all layers where it exists and remove it. No rebalancing required as well. So let's try to answer the question, which is why to use the skip list. The first thing, it's fast performance. I guess you can see this here. Skip lists offer average case time complexity of O login for search, insertion, and deletion, similarly to balanced trees. Simplicity as well, because unlike trees, skip lists don't require complex rebalancing operations. Also, dynamic updates. They handle frequent insertions and deletions effortlessly. Also, they are in-memory efficiency because skip lists are well suited for in-memory storage due to their lightweight structure. So the scenarios to use skip lists, it's used in Redis. Like Redis uses skip lists to implement its sorted sets. It have been used in databases because like skip lists can serve as in-memory indexing structure for databases. It's used also in distributed systems like skip lists, or often used in distributed systems like distribute hash tables for efficient key value lookups. Okay, so how we talk about how skip list stack up against other data structures. We talked about how it works against a linked list. Okay, I guess it's a better thing from a linked list. In the binary search trees, skip lists are simpler since they don't require rebalancing. In terms of if we want to compare it with B trees, like wild B trees are optimized for disk I/O. Skip lists excel in in-memory applications due to their lightweight nature. Okay, so let's talk about the limitations of skip list because it's pretty important. And the first thing in the limitations will be the probabilistic behavior means worst case time complexity can degrade to O of n, because again there is a probabilistic behavior, so we might go to O of n time complexity. Also, we have a slightly higher memory usage compared to binary search trees due to multiple levels, because we have more than one level, so we have more memory use. And yeah, this is the disadvantages that you have to put in mind. So I guess that's it for today's video. We just want to talk on high level skip list, and in terms of context, in the context of system design, you only need to understand how they work on high level. Maybe I'll create a lead code problems. I guess there are some lead code problems that talks about skip lists. We can work on them also. So for the meantime, I will say that's it for this video, and I hope you like my content. If you see my content quite helpful, please make sure to subscribe and hit the notification bell so you never miss any video, and see you guys in future problems.